everyone. Let's read the question. So an object of 5 centimeter in length is held 25 centimeter away from a converging lens of focal length is 10 centimeter. Now draw the ray diagram and find the position, size and nature of the image formed. Now let's write what we have given in this question. So first it is given that the object is 5 centimeter in length. So we have given data is, so object is 5 centimeter in length means the height of the object is given, height of the object. Let's write this as HO and the value is 5 centimeter. Now next, it is held 25 centimeter away from a converging lens. Now first of all, converging lens is what lens? A converging lens means a convex lens that converges the rays of light when incident on that lens. Now the focal length. So focal length is 10. First write what is 25 centimeter. That is away from the converging lens. So the object distance is given as object distance, that is represented by small u. The value given is 25 centimeter. Now focal length is given as focal length represented by small f, and that is 10 centimeter. Also, okay, now next we need to find the position, size and nature of the image. So object distance is represented by u, so we can find the image distance. So image distance is represented by v. We need to find this. Now as the object is always kept at left side, now from the number line, this is 1, 2, 3, 4 and all. This is -1, -2, -3. In upward side, this is 1, 2, 3 and so on. And in downward side, this is -1, -2, -3. This is negative numbers. So for object is always kept in left side, that is negative. So object distance will be -25. And the focal length for the converging lens or convex lens is always in the right side. Right side means that is positive. So focal length will be positive. And height of object. So object is always taken as like this, AB, and that is in upward direction, and upward is also positive. So H0 is also plus. Now using mirror formula, because mirror formula gives the relationship between U, V and F. So using mirror formula, that is 1 upon V minus now to find V. So we have lens formula, that is a relationship between V, U and F. So now we are going to use the lens formula, and that is 1 upon V minus 1 upon U, that is equal to 1 upon F. Now substituting the values here. So 1 upon V we need to found. So 1 upon V will be equal to 1 upon F. Minus term will be taken as positive at it is from left hand side to right side. So 1 upon U. Now substituting the values. So F is 10 plus 1 upon U is minus 25. So now after calculating this, we can write 1 upon 10 plus minus minus 25. So after taking the LCM of 10 and 25, we get 50. Now 10, 5 times 50. So 5 minus 25 2 times 50. 2 into 1, 2. So after solving, we can write this as 1 upon V will be equal to 3 upon 50. Now only thing need to remember that we need to find V, and here it is reciprocal of V. So we need to reciprocal, denominator will be numerator and numerator will be denominator. So V upon 1 will be equal to 50 upon 3. Now this is positive value. So V, after dividing 50 by 3, we get the positive value with 16.67 centimeter. Now here we have the image distance. So this is the distance of image at the distance from the lens. So the plus sign here for image distance shows that so the image is formed where it will form, because in number line right side is positive and left side is negative. So image is formed on the right side of lens, or we can say that is image will be formed behind the lens. And the nature of the image will be, because right side image is formed, so for right side image is real and inverted. Now next, to calculate the magnification, we need to use the formula for magnification. Now for lens, using the formula for magnification, so magnification represented by M, and that is equal to image distance divided by object distance. So we have both image distance and object distance. Substituting the values here. So image distance 16.67 and object distance is minus 25. As already we have found, 16.67 is the image distance and object distance is minus 25. Now substituting the values, and after calculating we get the value of M, and that is in negative 0.66. And as the magnification is unitless, because centimeter is the unit for image distance and centimeter also unit for object distance, so both unit will be cancelled out, so magnification is unitless. Now to calculate the size of the image, we need to find the image distance, height of image. Now to find this, as we know the relationship between magnification and height of image and height of object, so again using that formula, M is equal to HI, that is image height, divided by height of object. Now substituting the values here also, we have value of M. Now substituting minus 0.66, that is equal to, we need to find the image height divided by object height. We have already know, that is given in the question, that is height of the object is positive of 5 centimeter. So substituting here as 5. So HI, image height, will be equal to minus 0.66. Denominator is 1. After cross multiplication, we found that the height of object will be minus 3.3, and that is in centimeter. So we have, first we have position of image, and that is represented by V and given as 16.67 centimeter from the lens. Now next we need to find the size. So size, or we can say height of the image, that is represented as HI. So that is minus 3.3 centimeter. And lastly we need to find the nature. So nature of the image, and that is image is real, inverted and diminished. Now we need to represent this in ray diagram also. So here is the ray diagram. So this is the principal axis. Now we need to take, this is the center, optical center, then focus F1, then focus to F2, then this is focus and to F. Now we need to present object is like this, AB. Now we have two rays. So first one is passing parallel to principal axis, then it will passing through the focus. Second ray is passing through the optical center. Now these two rays intersect this point, so we get the image here. So this is the image. So we can write this as A dash B dash. So AB is the object and A dash B dash is the image. Now as the object is kept, the object's height is given as 5 centimeter. So this distance is 5 centimeter. Height of object is 5 centimeter, that is negative. This is the left side, so this is negative side. This is the midpoint. This is x-axis, this is y-axis. Now y-axis is positive. Now object distance is given as 25 centimeter. So 25 centimeter is u. U is object distance. So this is also minus 25 centimeter. Now also focal length. Focal length is given as 10 centimeter. Already we have found the V value. V is this direct. V is in other side as with respect to object distance. So V is given as 16.66 centimeter. So this is in right side. So this is positive. Now the positive value of V indicates that image and the object are in opposite sides. Also we have given the magnification, that is minus 0.66. So the negative sign indicates, this negative sign, that the object is inverted, and if m is less than 1, then that indicates that image will be always diminished or smaller size. As you can see, object is like 5 centimeter and image is 3.3, as the 5 centimeter is 3.3 centimeter is less than 5 centimeter. So also kept in mind, if m is greater than 1 no, then you will get the image enlarged, that is larger than the object's distance. So hope you find the video useful. Thank you.